AP Chemistry. I'm El Cocinero. Today we will be discussing periodic trends, the first of which is atomic radius.
El Cocinero? What is atomic radius?
Funny you should ask. Atomic radius is the total distance from the nucleus of an atom to its outermost electron orbital. Atomic radius increases down a group and decreases across a period. Now, you might be asking, why does this occur? I'll tell you. Atomic radius increases down a group because you are adding an electron sublevel to your atom, which means there is more distance between the nucleus of an atom and its outermost shell of electrons. And you might be thinking, that doesn't make sense to me, but it will. And this is also because there is more nuclear shielding. You'll learn more about that later. Now, it decreases across a period because there's a higher effective nuclear charge, which causes an increase in attractions to electrons, pulling the electron cloud in, thus decreasing the atomic radius. Let's try a practice problem. If you have an element in the top right, what do we think the atomic radius is going to be? You got it. Small. Now, if it's in the bottom left, what do we think it's going to be? Chunky. This has been your lesson on atomic radius. Please watch next for ionization energy.
Hola, soy el jefe. Now we will be talking about ionization energy.
El Jefe, what is ionization energy?
Well, when we talk about ionization energy, we're usually talking about first ionization energy, which is the amount of energy it takes to remove one little electron from an atom. Now, as we remove electrons from an atom, it becomes increasingly hard to remove the following electrons. So ionization energy increases with each electron removed because the atom becomes more positively charged, so the remaining electrons are attracted more strongly to it. Now, the further away an electron is from that positively charged nucleus, the easier it is to remove. This is why, as atomic radius increases, ionization energy decreases. So, ionization energy decreases down a group and increases across a period. Now, the reason that ionization energy decreases down a group is because down a group we get more levels of electrons, and the levels inside shield the outer electrons from that positively charged nucleus, so they become easier to remove. Now, there are some exceptions to these trends. Group 2 over here is harder to remove and has a higher first ionization energy than group 13 over here. This is because group 2 has this completely filled sublevel, whereas this one only has one electron in this outer sublevel, so that's easier to remove than this completely full sublevel. There's also another exception. Group 15 tends to be easier to remove than group 16 because group 15 has a completely half-filled electron sublevel. And that's ionization energy.
Welcome back, AP Chem students. Today we're talking about electronegativity. My name is El Carcinero.
El Cocinero? What is electronegativity?
Funny you should ask. Electronegativity is a measure of an atom's ability to attract shared electrons when bonded with another atom. So, in layman's terms, how much an atom pulls electrons towards it when it's bonded with another thing. All right, so electronegativity increases across a period and decreases down a group. This is because it increases across a period because of the added protons and the charge of the atom, and it decreases down a group because of shielding. All right, so for example, an element in the top right of the periodic table would have a high electronegativity. It would pull greatly. An element in those lower left-hand corner of the periodic table would have a low electronegativity because of increased shielding and decreased protons. All right, now exceptions to these rules are when an atom is bonded to itself, there is no effect because essentially the charges cancel each other out. So for example, if we have an oxygen-oxygen bond, they both have the same electronegativity, so when they're bonded with each other, they have no effect on each other. Hydrogen and noble gases are also exceptions to these rules. Thank you.
Hey guys, it's El Jefe. This is our We Do section. Make sure you follow along on your own sheets. First, we're going to be talking about the trends for atomic radius. Now, you all remember which way this goes, right? That's right. Atomic radius increases backwards across the period. And it increases down a group. You remember this. Now, ionization energy. Do you all remember which directions the ionization energy increases in? That's right. It's the opposite of atomic radius. It increases across a period. And it increases up a group. Now, electronegativity. This is the kicker. You all remember which way electronegativity goes? That's right. It's the same as ionization energy. It increases across a period and up a group. Now, you all pay attention to this table. This will be very helpful in doing your You Do problems. Good luck. Thank you for watching our lecture, AP Chemistry students. We hope you learned something. You're going to do excellently in this class. Good luck and goodbye.
Bye!